Welcome back to the Python tutorial series. I'm so glad you're here. This is the 51st video in the series, and today we will go over the binary search algorithm. We will first go over how the binary search algorithm works, then we will write code for it. So let's get started. So how does the binary search algorithm work? Well, you first need a sorted list, and as you see here, we have a sorted list 1, 4, 7, 8, 9, 22, and 80. So you're searching for a number, letter, or some value, and instead of searching through the whole list using a for loop, you start in the middle of the list, and you want to see what index something is in. And remember, indexing starts at 0. So 1 is in the 0 index, 4 is in the first, 7 is in the second, and so forth. What the binary search algorithm does, it starts in the middle. For example, there's 7 numbers here, so it starts at 8. So if you're looking for the number 7, it would start at 8, and it sees 7 is less than 8. So the end is now 7, the beginning is now 1. So now it searches 1, 4, 7, and the midpoint of this is 4, and it sees that 4 is less than 7. So now the start is 7, the end is 7, and that's how you get 7. But let's say you were looking for 5. 5 is less than 8, so you're once again looking at 1, 4, and 7. 4 is less than 5, so now you're just looking at 7. But since 7 is greater than 5, the end is going to go before 7. So now your end is before your start. So if your end is before your start, that means it doesn't exist. So the number isn't in there. That's an overview of how the binary search algorithm works. Now let's see the code behind it. I created a function called binary search that takes in a list of items and an item, and it's going to return the value of what index it is in. So the first thing I'm going to do is create a variable called start and set that equal to 0, the beginning of the list, and also a variable called end and set that equal to the length of the list of items minus 1. Now we want to create a while loop that runs as long as start is less than or equal to end. If not, there is no value. So while start is less than or equal to end, we're going to look for the midpoint. So we'll set midpoint equal to start plus, in parentheses, n minus start divided by 2. And we're using floor division here so it doesn't return a decimal. And you might be wondering, why do I have n minus start in parentheses? Well, I have that there because of PEMDAS. Otherwise, we could have some errors. So that's why it's start plus n minus start. That's not the same thing as just end. Now that we have our midpoint, we're going to look for midpoint value, and that's going to be equal to list of items and then the midpoint, since the midpoint is an index. And if midpoint value is equal to item, we have found the index, so we can return midpoint. Else if item is less than midpoint, we want to set end equal to midpoint minus 1. Otherwise, the item must be greater than the endpoint, so we can say else start equals midpoint plus 1. And then we are through our while loop. The only thing that the while loop doesn't check for is if the 0 index is equal to the item. So we'll say if list of items 0 is equal to items, we want to return 0. Otherwise, it's not in the list, so we're going to return none. Now to test if this works, I'm going to create a list called list1 and set that equal to a list of sorted numbers. Then I'm going to look for the number 2, and then I'm going to run that. So I'll print binary search list1 and a look. So this will look for number 2, and it's 1 because it's in the first index. If I wanted to look for another number, let's say 8, I could also do that, and it's in the 5th index. If I wanted to look for 9, I could do that as well. That's in the 6. And if I wanted to look for 1, it should be in the 0 index, and it is. And now this works. Thank you so much for watching. Make sure to follow along with this video series by subscribing and hitting the notification bell, or by clicking on the next video so that you can expand your knowledge about Python. And as always, I can't wait to see you next time.